And I'm not going to say quickly. We're not going to go through this quickly. We're going to go through this very slowly, very completely. Hold on. I think I have a place to get a circle here. Hold on. Where is it? Okay. Yes. If you look where the lectures are, you can see there's old lectures. If you need to review something, please review something. Oh, hold on. I'm getting closer. Okay, here we go. There we go. Circle. Okay, ready? So here's a unit circle. It's called a unit circle because out here at the edges, this is 1. Out here, this point is -1. So basically it's -1, 0, right? This point up here is 0, 1. This is the x-axis. This is the y-axis. Okay. So does everybody understand why these points I've labeled are those points? Imagine this without a circle on it, right? If I were to say that to the right is 1, okay, good. So everybody gets this. Thank you. So now what we're going to do is we're going to only look at quadrant 1. This is quadrant 1, right? We're only going to look at quadrant 1, and we're going to say, whoever's writing on the board, please don't. We can all see it. Okay? I'll give you a screen if we have a break. You can write on the screen as much as you want. If you have a question, you want to write it on the screen, that's fine, but don't play on the screen. It's public. All right. So remember last week we talked about this point here being 0 and also 2 pi, right? And this point here is pi. Up here we have pi over 2. I don't know why it's not writing very well again, but okay. And here we have 3 pi over 2. This is a 3 pi over 2. Okay. So also over here we have, this is 0 degrees. That's 0 degrees. This is 90 degrees. This is 180 degrees. And this is 270 degrees. 3 or 5. I'm not sure what that means. Oh, 3. Hold on. Okay? Yeah, 3 pi over 2. Remember we talked about it being 0 on the beginning, and then the whole thing is 2 pi, so it's 0, half a pi, pi, and 3/2 pi, which is 1.5, right? Okay, so now in quadrant 1, we have a point out, we have a line out here. This, even though it's not perfect, we're going to call this 45 degrees, which is the same as pi over 4. Okay? And out here we have a point that matches it called the square root of 2 over 2, comma, square root of 2 over 2. All right? And it comes from those triangles that we drew last week with the 45, 30, 60, 90, and 45, 45, 90. Remember that? Okay, good. So at 45 degrees, remember the height of this triangle is going to be exactly the same as the width, or whatever you want to call it, right? Hold on. So that's it's kind of easy to remember because the height and the base, we'll call it the base and the height, are exactly the same. So you have to remember these numbers. Square root of 2 over 2, comma, square root of 2 over 2. This is memorized. I will tell you when to memorize something. This is memorized. Then we have this is our 30 degree or pi over 6 line, okay? 30 degrees, pi over 6. And the point that's attached to that would be, now here's how you remember, there's actually 3 points you have to memorize. There's square root of 2 over 2. I don't know why the 2's, it doesn't like giving me the 2's. Square root of 2 over 2, and then there's the square root of 3 over 2, comma, it's a comma, 1/2. And then there's a third point where all that happens is the x and y values change. It's the square root of 1/2, comma, the square root of 3 over 2. So there's really only 3 numbers to remember. Okay? Now, here's how I remember it. Do your best to figure out a way for you to remember it. Notice here at 30 degrees, or pi over 6, now remember the smaller the fraction, the denominator, the bigger the denominator, the smaller the fraction, and the smaller the denominator, the bigger the fraction, right? So here at 30 degrees, at pi over 6, do you all see that the base is longer than the height?
Yes.
Good. So since it's longer than the height, which one of these, it can't be this. This is only for pi over 4. So we're just trying to figure out which direction these are going to go in. So which of these values, is the square root of 3 over 2 bigger than 1/2, or is 1/2 bigger than the square root of 3 over 2?
The square root of 3 over
Square root of 3 over 2 is bigger, right? Because they both are over 2, so square root of 3 is bigger than 1, isn't it? Okay, so that's how you can make the decision. So because at pi over 6, the x value is bigger than the y value, the point out here is the square root of 3 over 2, come on, draw me a 2, comma, 1/2. These are all over 2. I'm sorry they're not showing up very clearly. Okay? So that's how I remember which one's which. Because the next point is 60 degrees. So it's 60 degrees, or pi over 6. So this is 60 degrees, pi over 6, right? Well, which is bigger, the x value or the y value for the 60 degrees? Which should be bigger? I'm sorry, this is pi over 3, not pi over 6. Sorry. The y value. So we reverse it. Here, it's the x value is smaller than the y value. Does that make sense? Okay, so this is basically what you have to memorize. What I've just told you is what you have to memorize. And I'm going to show you, if you know that information, here, I'm just going to get rid of all the rest of this stuff down here. So what I want to show you is if you have those few points, then what happens is the rest of it's pretty simple. Because, well, remember we talked about reference angles last week? So anybody who didn't watch the lecture last week, it's recorded, just go back and rewatch it. If you watched it, if you were here and you didn't understand some stuff, go back to the lecture, rewatch it. If you want, you can always come see me in office hours. That's fine. Or you can request online office hours. That's fine as well. But, so, what I'm going to say is, well, remember we said this short one here, the reference angle here is pi over 6, right? Because it matches this triangle over here, which is pi over 6. So that means the x values have to be the same length and the y values have to be the same length. The only thing that's going to change in quadrant 2 is the values here, instead of being positive the square root of 3 over 2 comma 1/2, it's going to be negative the square root of 3 over 2 comma 1/2. Yeah, the only thing that changes is the sign, right? And the x value is negative, the y value is positive. And the same thing is going to be in quadrant 3. So if you know what quadrant you're in, down here, where the reference angle is pi over 6, it's going to be negative the square root of 3 over 2, comma, negative 1/2, right? And then the same thing happens in quadrant 4. If you have pi over 6 as your reference angle, you're going to have positive the square root of 3 over 2, comma, exactly, negative 1/2, because the x is positive, the y is negative. So do you see why? So now, given everything we've talked about from last week and this week, right, all I need to know is my reference angle, what quadrant I'm in, and it is really easy. And the points in quadrant 1 that you're going to memorize. And listen, it's not going to be that hard to memorize this. Please memorize it like as soon as possible. The sooner you memorize it, the easier this class will be. Okay? I have people in the middle of the semester still don't know the unit circle. It shouldn't be that hard. It should be something, memorize quadrant 1, and then it literally matches all around the circle with reference angles. Okay? Okay. So let's do some practice. Let's see what we have. Well, I wouldn't say that. I would say the unit circle is, let me put it this way. If you get to algebra and you can't add, subtract, multiply, or divide, how good do you think you're going to do in algebra? Right? Now, would you say that 80%, 70% of algebra is arithmetic? Adding, subtracting, multiplying, dividing? I would not say that. But I would say that without that skill, you can't do algebra. Does that make sense? So without the skill of this unit circle, you can't really do trigonometry. But it's not 70% of the course. It's the base, thank you. Okay? So it's as important to the course as your basic arithmetic functions. Okay. Onward. So now here's prettier pictures. I know my pictures aren't great, but I think when I explain them, it's easier for me to write stuff. All right, so as you can see, here's the exact same points we just talked about. I'm not going to talk about them again. These are the points in the first quadrant. And then here's more about reference angles. We already talked about reference angles last week, didn't we? So I'm not going to go over reference angles again. Out of it by itself, I will always go over reference angle in context. Okay? All right, so now, finding points on the unit circle associated with a rotation. So determine the reference angle for each rotation given, then find the associated xy on the unit circle. So what's my reference angle for A? Who can tell me what my reference angle for A is? First, what quadrant is it in? So quadrant what? It's in quadrant 2. Excellent. And the reference angle, and I'll call that theta sub r, is equal to pi over 6. Exactly. How many people don't know that? It's okay if you don't, because just because 10 people out of 41 can answer correctly, I will never make the assumption that everybody knows. So how many people don't know where I got this from? And you don't have to stay quiet. That's why I'm here. Okay, Matt. So were you here last? I mean, I'm not trying to put anybody on the spot. I'm just trying to figure it out. So the people who are saying me, were you here last week? Okay. Okay, no problem. Then let's go over it again. Well, 5 pi over 6. Don't make the assumption. So 5 pi over 6. First thing you want, does everybody see why it's in quadrant? Does everybody know why it's in quadrant 2? Does anybody not know why it's in quadrant? Okay. So remember, up here at the top is pi over 2, and over here is pi, and over here is 0 or 2 pi, and down here is 3 pi over 2. You have to know this, and your fractions have to be excellent, okay, because we're going to only talk about fractions a lot. This whole class is basically fractions. That's one of the reasons why it's harder. So 5 pi over 6, just think about the, so think about this as 0, 1/2, 1, and 1 1/2. Okay? Don't worry about the pi right now. So if I say 5, 6, is that bigger or smaller than 1/2? Is 5, 6 bigger or smaller than 1/2? It's bigger, right? Is it bigger or smaller than 1? Smaller than 1. So it has to be in quadrant 2. Is that clear? So Matt, Tim, I can't remember all the other people that said they didn't understand. John, I think you were one. So Matt, I remember Matt and Tim. Does this help? Do you understand why now it's in quadrant 2? Okay, good. So quadrant 2, check. Does anybody not understand why it's in quadrant 2 now? All right, very good. Now we say, okay, it's in quadrant 2. The reference angle is always the angle that the terminal side makes with the closest x-axis. So here's an important feature. Reference angles, sorry, this is not really my handwriting, some of it has to do with writing on the screen. Reference angles always less than 90 90 degrees, pi over 2. So it's always less than 90 degrees or pi over 2, and always positive. So if you give me a reference angle of 7 pi over 6, you're wrong. Even 5 pi over 6 is wrong because that's more than, that's not in the first quadrant. Basically, reference angles have to be in quadrant 1. How's that? Okay? So now we have, if this is 5 pi over 6, and we know that all the way to this point here is pi, well, isn't it pi minus 5 pi over 6? Yeah, which is pi over 6. So pi minus 5 pi over 6. Okay? Who doesn't understand still? Anybody? Okay, good. All right, very good. So, what do you mean? What equation? Pi minus 5 pi over 6? Well, if I have a circle, here's my unit circle, right? And I've got this line . Yeah, what's pi? Pi is the same as 6 pi over 6, isn't it? Is that the question? Is that the problem? Yeah, pi is 1 pi minus 5/6. It's just fractions. Is that clear up for everybody? All right. Just trying to get myself some space here. All right, so B, 4 pi over 3. What quadrant is it in? It's in quadrant 3. Very good. Because it's more than 1 and less than 1.5. Right? Perfect. So now, remember, pi over 6 is the smaller angle. Pi over 3, remember, the bigger the denominator, the smaller the number. The smaller the denominator, the bigger the number. So pi in quadrant 3, this reference angle is what? Exactly. The reference angle is equal to, come on, draw it right, pi over 3. All right? Now, pi over 3, oh, we didn't determine the point on the unit circle, I'm sorry. So for pi over 6, reference angle pi over 6, what's our point for pi over 6? Remember, is the x value bigger than the y or the y value bigger than the x? X is bigger than y. Exactly. So that means we have to do the square root of 3 over 2, comma, 1/2. Right? That makes the x value bigger than the y value. Now, in quadrant 2, are they both positive? X is negative. So that's our point on the unit circle. Okay? That's it. It's really this simple. It's a couple-step process. So we know pi over 3 is a reference angle. We know it's in quadrant 3. What's our ordered pair for pi over 3? For pi over 3, is the x value bigger than the y, or the y bigger than the x? Nope, that's for pi over 4. Pi over 4, they're equal. Pi over 3, the y value is bigger than the x, exactly. Okay, and in quadrant 3, what are the signs? They're both negative, exactly. So negative and negative. All right? Are we catching on at all? It's pretty easy, right? Once you get the basics, it's not that hard. Okay, so now 7 pi over 4, what quadrant are we in? Remember I said change it to mixed numbers. Let's do that. What is it? Yeah, you're right, Anka. So what is this? What is 7 pi over 4 in mixed numbers? You know what I mean by mixed numbers? Like whole number and a fraction. So this is, remember, this is 1 3/4 pi. Okay? So that's more than 1.5 and less than 2. So that puts us in quadrant 4. Exactly. Okay? So what's our reference angle? Pi over 4. Now pi over 4 so we know pi over 3 and pi over 6 change off square root of 3 over 2 and 1/2. This is the one that's equal, so it's the square root of 2 over 2, comma, square root of 2 over 2. And in quadrant 4, what's negative? The y is negative, and boom. That's it. That's all there is to it. Okay?